not saying I don't like polarize, but like I don't have it. When it's like 1 against 5, it's just like.
Wait, are you talking about how it's kind of slanted? Okay, listen, we all have problems, okay? I don't know how to use the copier.
Oh my God, if you had this morning.
At Berkner, we had someone who just was like the copy slave, that you just tell him like. And I would like buy him stuff, so he would make my last minute. Now, like some. And free calculus. But then when I came here and I have to make all my own copies like a peasant, you know, so other school, I would just be like, hey, can you make these in 5 minutes? And he'd be like, yeah, you do it. But now, I would like bring him donuts, you know, every now and then.
School.
Huh?
The school. You know how much they pay them?
I have no idea how much they paid him. But he was chill, you know. Okay. Hello, how was your weekend? Terrible.
What are you doing?
All right.
Oh, besides that.
Okay, so you are looking at your semester exam review. Now let's take a walk in the past, okay? Ready? First and second derivative test. You just learned this. Okay, turn the page, part 2. You have derivative graphs. That's the last thing we just barely did on Thursday. Okay, then keep going. You'll see implicit differentiation. Okay, and then we're all getting PTSD because of related rates. It's fine. Okay, then the last section in this packet is your derivative rules. Okay, you'll see product rule, quotient rule, chain rule. Okay, now you'll notice there's one topic that's missing. Can you guess? Starts with the L. Limits, okay? And it's just because I didn't have time to do all that because I was in the woods all weekend camping with my friends. So you have almost all of your review, but you'll get just the limits part on Wednesday. So it'll be in 2 halves, but that part will be shorter than this half. Yes? I believe the final is 30 questions. It is all multiple choice, but you won't get a cut. Because your calculators can basically do half the stuff that you have to do by hand. Okay. So, that being said, our goal for today is going to be to work through first and second derivative tests, graphs of derivatives, and then a little bit of implicit. And then I'm going to give you some time to work. We'll do a couple examples from each section, and then y'all can move back into tables if you want. 3rd period was my last class that was tested. Okay? All right. So let's get started with the second question. Now you'll notice that the numbering on this is crazy because I just pulled them off of AP test, practice test. So if you're wanting to be on the same page as me, I just hand wrote little numbers down there. So we're on page 1, second question. Okay. So it says, what are the values of X for which F, given by this little equation, is increasing? Okay, remember, you're in the first and second derivative test section. Which type should I do? A first derivative or a second? Okay, F increasing is a first derivative question. Also, do I want the first derivative to be positive or negative? Okay, very good. So I'm going to put first derivative test. And then specifically, I want F prime to be positive. Okay, because if you don't know what you're trying to find, then it's going to be harder to know where to start. So I want to take the derivative of this equation. I'm going to write it a little bit bigger here. But it says x squared minus 3 e to the negative x. How will I take the derivative of that? There might be a rule involved. Okay, so chain rule is correct, but also what do we need? Product rule. Okay, because you have x squared minus 3, and then that's multiplied by e to the negative x. So let's break it up into our pieces. Okay, my u is going to be x squared minus 3. My v is gonna be e to the negative x. And then we're gonna take the derivative of both of those parts. What will u prime be? 2x. What will v prime be? So e to the negative x, the derivative is e to the negative x again, but then chain rule says that whatever the exponent is, if it's not just an x, you have to multiply its derivative at the back. What's the derivative of negative x? -1. So I need to times by -1, and I'm going to write it in the front so that we don't forget that's multiplied by -1, not a subtract 1. Okay, from there, let's do our diagonals. So we want this plus this, okay? So f prime of x equals. Oh my God. Okay, f prime of x equals. We have 2x e to the negative x plus, and then we have x squared minus 3. And then if it's a negative e, I'm going to take this plus here and just switch it to a minus. Okay, and then e to the negative x. Okay. So originally you do diagonal plus diagonal, but because this diagonal has a minus already in it, I'm just going to make it a subtraction in the middle. Okay, from here, I take the derivative, I set it equal to what? 0 is correct. So we have 2x e to the negative x minus x squared minus 3 e to the negative x. So I take the derivative, I set it equal to 0. Okay, remember you're looking to factor this. So if I'm looking at that, what do I notice they both have in common? Let's take that e to the negative x and GCF it to the outside. So my e to the negative x is going to come out to the front. Let's see what's left over. Okay, remember you originally had 2 pieces of your product rule. This is term 1. This is term 2. I'm taking e to the negative x out. What's left over from the first term? 2x. Very good. What's left over from the second term? X squared minus 3. But what sign in front? Minus. So I'm going to go ahead and distribute that. So this is going to be a minus x squared. And then what type of 3? Plus 3. Now, you should notice that even though this parentheses is out of order, we can tell it's factorable. We just need to put it in like ax squared plus bx plus c. Now, would it be a good idea to keep my x squared negative if I know I'm going to have to factor? No. So you're going to want to take the negative from here. We're going to GCF it out to the front. And then I'm going to reorganize that so that it comes in order. So the x squared used to be a minus. Now it's a positive x squared. What about my 2x? Negative 2x. And my plus 3 is now a minus 3. Okay, but you have to take the negative out so that your trinomial can be factored. Okay, from here, set up your little AC chart. Okay, I have A, B, C. Okay, we need numbers that are going to multiply to 1 times -3 is -3. And then we need to have a basement number of -2. So what numbers will times to 3? Only one pair. Okay, 1 times 3 or 3 and 1. Where do I put the minus to keep the 2 in the middle negative? On the 3, very good. So my factors are negative e to the minus x, x plus 1, x minus 3. This is your fully factored first derivative. Let's identify our critical numbers. Let's start with the parentheses. If I have an x plus 1, what's the critical number that goes with that? -1. Okay, then x minus 3 gives me what additional critical number? +3. Now, let's just talk about e. E to the x, does it ever cross 0? No, neither does e to the negative x. Okay, so this guy is not gonna give us any additional answers. Okay, really, e to the x, e to the negative x, it never crosses zero. You don't care, but pretend. E to the x is exponential growth. E to the negative x is exponential decay. So it starts high and then it asymptotes this way towards zero, but it never gets there, okay? So we have two critical numbers, set up your number line. -1 here, 3 here. And remember, when we plug in, we're plugging into the factored form. We don't care about the number, we just care about the sign. So pick a number bigger than 3. What can I pick? 12, great. Okay, 12 minus 3, positive or negative? 12 plus 1, positive. Now remember, E is always positive. Doesn't matter what number you put up top. But then your E has a what multiplied with it? A negative. So that front term out there, this is always going to be negative. This part is going to be always negative. Okay, because E by itself is always positive, but then there's a minus in front of it. So for that section, we got plus, plus, minus. When we multiply that together, what's the overall sign? Minus. Between -1 and 3, let's pick 0. 0 minus 3, how's it come out? Negative. 0 plus 1, positive, and this is always negative. So it's minus plus minus. Overall, what's the sign? Positive. Okay, last one, less than -1, let's pick -10. -10 minus 3 more. Negative, good. -10 plus 1. Negative. And then this is negative as well. That's 3 negatives. How many of them can cross out? Only 2. That's going to leave me with 1 left over. Now remember, if that's f prime, that tells me what f is doing. F would have been decreasing, increasing, decreasing. Now, they're looking for increasing intervals. So look at your answer choices here to the side. Okay, which one of those do we want? D is correct. Okay, we want from -1 until 3. That would be your increasing interval. Okay. Questions on that? Okay. Also, one other note. This is a first derivative test, yeah? Can you identify the maxes and mins from this? Yes, so at -1, what type do I have? Min versus at 3, I have a, it's very good. All right, go ahead and turn the page. Let's go on to number 24. Okay, this is on page 2. Okay, so back of that same page, but number 24, the middle question on page 2. Okay, it says, where does G have an absolute maximum? Okay, now the start of this is the same. Take the derivative. So here's your G of X. So what would G prime of X be? Okay, 4x3 minus.
4.
Good, because I had to divide by 3, and then when I multiply by 3, those cross out. Okay, and then my x is to the second power. Okay, from there, we're going to take the derivative, set it equal to 0. And then what can I take out of both of those? Okay, 4x squared. That's going to leave me with what? Very good. Okay, my critical numbers come from that test. I have an x on the outside. What number does that go with? 0. And then I have an x minus 1 gives me 1. Now, if it said relative mins and maxes, I would do a sign chart and I'd look for maxes and mins like that. It says absolute. Remember, for an absolute, you don't care if they win in their area. You care if they win in the interval that's given. So this is where you would do a candidate's chart. Okay, and remember, in the candidates chart, the only numbers that you're gonna put in are the end points and the critical numbers, and then you're just gonna see who has the biggest Y value. And you don't care how the slope changes, you just care about who's the biggest. So my interval is from -1 to 1. So those are my endpoints. And then out of my critical numbers, what additional candidate is gonna get to go in the table? 0. Now, 1's already in there, but let's say that 5 was also a critical number. Would it make the table? No, because it's not within the interval of -1 to 1. Okay, then you're plugging into the original function g of x. And all that you want to know is who has the biggest y value. Okay, versus if it had said absolute minimum, you'd care about who has the smallest. All right, let's start with 0. 0 is going to be the easiest to plug into. 0 to the 4th. And then -4/3, 0 cubed. Okay, what's 0 times anything? 0. So basically I'm doing 0 minus 0, which gives me. Okay, let's do 1 next. 1 to the 4th minus 4/3, 1 cubed. What is 1 to the 4th? Okay, 1, because remember, it's 1 times 1 times 1 times 1. So I have 1 minus. And then 1 cubed is another 1 times it by 4/3, it's going to stay. Now, what's going to be a little bit tricky for your exam is you don't have your calculator. So let's review how to do this. I want 1 to be a fraction out of thirds. How many thirds do I need to equal 1? 3/3. And 3/3 minus 4/3 is -1/3. Okay, then to be a little bit lazy, I'm just gonna switch to the little minuses. Okay, right there. Now it's -1 to the 4th. How's that gonna come out? Still +1. Okay, but then here, watch what happens. My -1 to the 3rd is gonna come out how? Plus or minus? Minus, but then I have another minus is going to switch this to a plus. So I want 3/3 plus 4/3, which is going to give me how many? 7/3. Okay, now looking at my answers, I'm looking for the absolute max. Which of these numbers is the biggest? 7/3. And is it an option? Which answer choice says 7/3? It's none of them, right? Okay, so let's read the question again. It says, at what value of x does g have an absolute max? So the absolute max is 7/3, but it happens at x equals what? Very good. So it is 7/3, but it occurs at x equals -1. So -1 would be the answer. Okay, this is the highest it goes, but it happens at that x value on the graph. So just be kind of careful. I'm not going to do the next question, but it wants to know where the graph is what? Is that a first derivative test or a second derivative test? Second. So if you want to make yourself a little note here, okay, concave up is a second derivative test, and if you need help with that, then you know when we split for y'all to work. All right, go ahead and turn the page. Next one we're going to jump ahead to is going to be number 25, the middle question on page 3. You have a little table here. Okay, so it says f is a twice differentiable function. Here's all that means. That means you can take the derivative of it twice. Okay, so don't get tripped up on that. Twice differentiable means you can take the derivative twice. Notice that I can tell that because they gave me numbers for the first and second derivatives. Okay, then it says, which of the following are true? F has a relative minimum, maximum, okay, at 2 and at 8. Is this probably asking about the first or second derivative? Okay, if it's saying words like minimum, maximum, 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 this is a first derivative test question. So look at your first derivative and let's find our critical numbers. Remember that critical numbers are the first derivative row equal to 0. Where does that happen? X equals 2 and 8. So now we see where they're getting these numbers from, right? That 2 and 8 are the critical numbers. There are 2 ways for you to identify mins and maxes. Okay, the first one is to do a sign chart, but here's the problem. Okay, I know, let's go to 2, for example. Okay, my derivative is 0. I know I have a flat spot. What is the sign of f prime on the left of that? -1. And what about on the right? Negative. So you would probably say it's a neither, right? Because it goes from negative to negative. Okay, the problem is we don't know what if it changes sign at 1 and it just didn't make the chart. So there's another way that we learn how to tell if it's a max or min, and that's with concavity. So at 2, can you tell me what f double prime is? Is it a positive number or a negative number? Okay, so I'm going to put f double prime is negative. That means that f is what concavity? Concave down. Okay, then on your paper, I want you to draw me a little concave down, so a little frowny face, and then find the spot on that where the slope is 0. That would be this guy right here. Is it a max or a min? Okay, then this has to be a relative maximum. Okay, so there are 2 ways for you to identify maxes. If you have enough information to do a real sign chart, that works. But if you're looking at a table specifically, we don't have enough information to do a sign chart, but we can do a concavity check. Now go to 8. What's my second derivative? What type of number? Positive. F double prime is positive. And what does f double prime being positive mean? That means that f is what? F is concave up. Draw yourself a little up like a cup. Find the flat spot, because remember, we already know that the derivative is 0. That means I'm on the flat spot. Then what type of extrema does that have to be? A minimum. Okay. And then we're looking for which of those statements is true. So statement number 1 says f has neither a min or a max at 2. Do we want that? No. Statement 2, f has a relative max at 2. Do we want it? Yes. And then do we also have a max at 8? No, it's a min, so we want it. Okay. All right, we're going to do 2 more examples and then I'm going to let you work. Turn for me, please, to page 5. We're going to do the bottom one first, and then we're going to do the top one, and then you're going to have some time to work. This is what we just covered last class. So what is this a graph of? Read it carefully. F prime. This is a graph of f prime of x. Now, the questions that are the answer choices are talking about the graph of what? F. Is this a graph of f? This is f prime, right? So we're going to use the graph of the derivative to answer questions about a graph that we don't have. So first question, find where f prime of x equals 0. When f prime of x equals 0, those are your critical numbers. Where does that happen? At 0 and 2. Very good. So let's do a first derivative test here. Okay, at 0 and at 2. Before 0, where is f prime? Is it in the positives or the negatives? It's above the x-axis is positive. What about between 0 and 2? Negative. And now I want you to extend the graph. Pretend it keeps going up higher. Okay, then where would it be after 2? Positive. Now, if f prime, the graph I'm looking at, if f prime is above the x-axis, what does that tell me that f would have been doing? increasing, very good. So my graph that I don't have a picture of goes uphill, downhill, uphill. Now, not only can an F prime graph tell me increasing or decreasing, it can also tell me about the concavity of the original graph. What feature in this graph will tell me about concavity? The slope. Very good. So put a little star here. F double prime is the slope of this graph. Okay, and for this graph, where do I have a slope change? At 1, very good. Okay, and at 1, what happens to the slope? It goes from downhill to what? Uphill. So if it goes from downhill to uphill, that means your original graph that you don't have a picture of goes from concave down to concave. Now, let's talk about this little flat spot here. What is your slope at this point? 0. If you have a concavity of 0, that means your graph is perfectly linear, that it doesn't have a bend. That doesn't happen on your exam, but since I wanted you to kind of think about what we did last class, I had you do it. Okay, so now let's look at our answer choices, see which one is correct. We want to know which one is true. Is F increasing from -1 to 1? Look at your derivative chart. From -1 till 1, is it increasing? Oh, sorry, decreasing. No. Now, is this graph decreasing on that interval? Yes, but that's not what I'm looking for. I want this graph to be below the x-axis all the way from -1 to 1. That's not true. Okay, F is increasing from -2 to 0. Look at your graph. From -2 to 0, am I above the x-axis that whole time? Yes, then that's going to be your graph. Okay, for F to be increasing on 1 to 2, I don't care that it's uphill. I need it to be above, right? And then for my next one, part D, it says I have a local min at 0. What type of extrema do we have at 0? This would have been a max. Okay, and remember, even without drawing the sign chart, you can tell that this is a max because of the direction of the sign change. Okay, if it goes from above in the positives to below in the negatives, that means the slope of the original graph would have gone from a positive to a negative, and I can kind of draw out in my mind that that's a max. Okay, what type would this have been? At 2. It would have been min. Now, obviously, it doesn't keep going, but if it did, you would pick that. Okay, now go up to number 21. Okay, the last thing we did last class was to sketch graphs of F. So you have a chart that has information about F prime and F double prime. We need to pick which graph matches that. So let's go little piece by little piece. From 0 to 2, what is the sign of F prime? Negative. What does that tell me F needs to be doing? Decreasing and concave down. Okay, look at your graphs. From 0 to 2, which one is not decreasing concave down? A is not. Which other one? B is decreasing concave down, isn't it?
Oh.
And then this one is, but this one is increasing, so D is out. Very good. So A and D are already out. Let's look at the next interval. From 2 to 4, what is the sign of F prime? So it must be increasing. And then what's the second derivative sign? Negative means concave down. So from 2 to 4, my graph needs to be increasing concave down. Look at your graphs. From 2 to 4, this one is increasing, but what's the concavity? Up, and I want down. This one is increasing concave. So it has to be answer choice B. Good? Okay. I think that's all I did with the other class. We are gonna do a couple questions from implicit, but not right now. So we have still almost an hour left in class, so let's do like 25 minutes. Work on those 2 sections, ask me if you need help, okay?